Hello everyone. I'm Noura Abdelmajid, along with Circle Schindler, Friedrich Schiller University, Jena. And today I'm going to present JenTab, a toolkit for semantic table annotations. I would get started with the semantic table annotation tasks. At first, we have CA. It basically assigns Wikidata identifiers or knowledge graph identifiers in general to individual cells. And for the CTA, it matches the entire column to a semantic type. And the last one, CBA, captures the relation or the semantic relation between two columns. Here is the rest of the outlook for today. And the next section goes to the related work. We have grouped the related work into three main categories. They use benchmarks for the evaluation, the JenTab challenge participants over the last 2 years, and another approaches which combine machine learning to solve one or more semantic table annotation tasks. For JenTab, it's actually unlike the existing state-of-the-art methods. It's basically a modular approach, solves the three tasks jointly with minimal data sources. I would explain that in a while. For the proposed technique, in the following, I would cover the used pre-processing steps, the choosing CFS pattern, our context and the annotation modules for the pipeline, and finally the architecture. For the pre-processing, it involves three tasks. The generic fix, including the encoding fixes and the restoring missing spaces or something like that, like parse errors. And for data type detection, prediction for actually columns, we restricted the choice of the data type per column to those which have equivalent types in Wikidata. So basically we have those four: object, quantity, date, and string. And finally, we have the type-based cleaning. Basically, we try to extract the relevant part from quantity and date from the given cell value to facilitate the matching. For a CFS pattern, in summary, it uses knowledge graph lookups given various constraints and assemble all the retrieved information from them and picks the final solution at the end. So it has three stages. At first, it creates all possible candidates for the three tasks. Then it filters this initial candidates by using the feedback from the others, and finally select the most suitable candidate from the remaining ones. Here, the data sources we are currently using, the lookup services over the knowledge graph and the Sparkle endpoint. We leverage four contexts to create and filter annotations. At first, we have the cell context, which actually uses only the plain cell value. We have also implemented various strategies leveraging this plain cell value. The second one is the column context, which actually leverage the semantic column type besides the plain cell value. And for the row context, it's actually a bidirectional context. Given a subject cell, we try to infer the properties from that, and the other way around. Finally, the most accurate, the most accurate context, which is actually row and column at the same time. So basically, it combines both of them. For black box execution, given the annotation module CA label lookup and also given the context of the cell value, we query the knowledge graph using this cell value only, and we expect multiple candidates as a return of that. For this annotation module, we have in total 6 strategies. The first 4 of them are actually here in the table. And the last 2 columns shows an example for each one of them. And for each type of this strategy, we try to capture a different part of the cell value to have different candidate from the knowledge graph. The last two are meant to be autocorrection. The first one, the generic lookup, is actually pre-computed and uses the Jaro wrinkle distance. However, the autocorrect uses the one edit distance, and it's also on-demand execution. Again, a black box example for the JenTab execution given the CA by column. As you see here, one more accurate candidate is only remained from or compared to the other execution. And this is actually another or alternative execution given the raw context on the right, and these two annotation modules, and for this example, it have the same output. For creation CTA or for creation types for the column, it actually collects types for all retrieved cells. And for the CBA for properties, it do the same concept for object properties. However, for literal properties, we implement fuzzy matching. For example, we tolerate 10% of numbers, for example. For the filtration modules, it tries to get rid of those highly unlikely properties or candidates in general, not only properties. For example, this CTA support, it removes those column types that are less supported by other candidates. And the same idea applies to the properties here by the CA task. And finally, the CA by string distance, it also removes those values that are far from the original knowledge graph label. The final stage for selection, it actually picks the solution. Here we have like multiple multiple methods do the same task, and those are the dominant ones. For example, this CA selects the closest knowledge graph label given the Levenshtein distance, and for CTA we have LCS or majority vote. I would explain that in the next following slides. And for CBA, we have only CBA by majority vote. So basically, it picks the most co-occurred property. Here is more details about the CTA selection. At first, CTA by majority, given this example on the left, and we have types given the B31 from Wikidata. So the CTA by majority would consider only this part highlighted in red, and picks the most co-occurred type at the end. However, in CTA by LCS, it considers the entire hierarchy and applies the least common subsumer. So basically, it would pick the lowest node with the highest coverage. In this case, the solution would be more accurate than this general one. CTA by direct parents, it involves one level up and then flatten all of these and picks the most co-occurred one using normal majority vote. For our pipeline or the sequence of modules, we have these 9 groups. So the first one represents our core pipeline, and we do not apply any kind of selection here. While in the 9th group, we have our last resort or all attempts of selection in case one it would fail, then it goes to the another one. In between, it's just a mixture among the creation, filtration, and selection. From the architecture point of view, JenTab is a distributed system with one central point or node named the manager for workload balance. For the other components, they are implemented in isolated services. So the chosen architecture enables scalability and knowledge graph substitution. In terms of the used data sets for our evaluation, basically this table shows statistics for a 4-round challenge given by Semantic 2020 last year. And in total, we have more than 130,000 tables. And this is actually a mixture between the automatically generated dataset and the tough tables dataset by the challenge community. We have encountered 11 challenges for the given data set. At first, the column header or the metadata is always or frequently missing. The second one, we have encountered a lot of spelling mistakes, and we have also some ambiguity, or actually a lot of them. We have checked the missing spaces and the inconsistency of the format. Some cells have like multiple pieces of information in the same, the cell value. For redundant columns are detected here. We have some kind of noisy data. I would expect Perlin inside this column instead of Tübingen, for example. And we have some missing values, not in one format, but in more. And finally, the two excessive lengths of tables. For the evaluation matrices, we have stick our evaluation to those announced by the JenTab challenge last year for comparison reasons with other system participants. For CA and CPA, we have used the standard precision recall and F1 score. However, for the CTA matrices, we have used this kind of a special score which pays attention to the hierarchy of the solution we have predicted. So a partial score would be given to a more general solution rather than 0 or something. Our experiments, we have conducted like 3 modes solving the CTA, and our question which one of them would have the best scores. So from left to right, the solution tends to be more general. And for our first mode, we name it like B31. So we include only the leaves from the types hierarchy and apply majority vote on that. And for 2 hops, we include 1 level up. And for multiple hops, we consider the entire hierarchy. For our results, the following would have the individual components evaluation for the JenTab. So at first, the pre-processing, specifically for type prediction, we have achieved 99% accuracy, distinguishing among the column data types. And for the generic lookup, we have achieved high coverage. So for the first 3 rounds, we have achieved near 99%. And for the last round, we're almost 97%. But this component is actually computationally expensive. Since we have various strategies solving the same task, so we have also computed the effectiveness of each of them. So at first, the creation strategies for CEA. So basically, the graph here actually reflects our priority. So which one should be executed before whatever others. And for the selection strategies for also CEA, we have set the string similarity as our dominant one. And in this case, it actually succeeded to solve like 38% more than the other backup strategy. For the CTA creation, for CTA selection in the mode of B31, the majority vote here is set to be the dominant one. I would like to compare that directly with the CTA with LCS. In this case, you would notice compared to the other one, less reliance on the backup strategy, which means LCS succeeded to solve more than the majority vote in general. Here is our scores compared to JenTab challenge top participants. And JenTab is actually one of the top 5 systems of the CA and CTA task. However, it's among the top 3 systems for CPA, given that we do not have any offline Wikidata dump, and we do not use any generic search engine. Here's also one insight about the tough tables performance. So for the automatically generated data set, B31 was sufficient and gives the best scores, which is unlike the case in more hard data set. So 2 hops gives the best scores in this case. Multiple hops mode in the 2 data sets gives the lowest scores, I would say this is due to the more general solutions. It won't be correct, but not the best solution. So, of course, lower scores. In terms of the execution time, we have implemented a time scoped execution. So, for example, we set like 1 hour to solve the entire table. So this achieved a faster conversion. For example, for the fourth round, we have managed to reduce the time required for it to like 50%. In summary, I have presented JenTab Toolkit, which is publicly available here in this URL, and it uses minimal data sources for knowledge graph, only the publicly available data sources, and it uses also the CFS pattern, and we have explained the 3 experiments for the CTA solution with their detailed analysis. Our future work considers optimizing certain components that takes substantial resources like the generic lookup, and also to dig deeper into tough table dataset. Last but not least, we'd like to thank the following people, and thank you all for your attention. So please, if you have any question, please go ahead.
Right. Thank you, Nora, for your presentation. I can already see one question in the chat. The question is, how do you select the result if 2 high confidential candidates are not in the same tab hierarchy? It's about the CTA task, the question.
I'm trying to access Zoom again. Sorry, if I got the question correctly, so how do I select from the CTA if 2 are?
If 2 high confidential candidates, candidates are not in the same type hierarchy.
Are not in the same type hierarchy. Basically the 2 of them are not really connected by one top parent or something.
I would suggest that maybe, how can I pronounce diction?
Okay, wait. Hello. Hello. My question is quite simple. It's just I noticed that you use a CTA annotation with by leveraging the hierarchy of the types, and you tackle several operations on that. And we're doing the same experimental and the core also of the Dagobah that you mentioned. And we are facing a problem that in some cases, we find out that it's not, in some cases, it's not very easy to have all the high scoring candidates are in the same hierarchy. And so I wanna ask you, how do you tackle this kind of situation? Thank you.
Actually, yeah, thanks for your question. I'm not so sure if this applies here. I mean, we assume that all types belongs to Wikidata hierarchy. So at some point they must be interlinked to some general parent, I would say. So your case, it's actually interesting for me, and then maybe I would like to look for that deeper, yeah. But at the moment, I don't have something specific handling this case, I would say.
Okay, thank you.
Thank you.
A quick question from my side. This is more on the side of the benchmark in general. I noticed that for some tasks, the F measure were around 99%, from other almost 99.9 or so on. Usually this is a sign that you need a new benchmark that is even more difficult. What do you think about this? Because it seems that in some cases we are very near to almost completing this benchmark, and maybe we need more other cases. And what do you think this could be?
Just to make sure, so 99% for this case, or for the other one, the generic lookup?
Well, I saw that there were at least a couple of categories that were basically multiple systems were obtaining very near to 99%. This usually suggests that you need other benchmarks. Otherwise, everybody will just play on the 99.1, 91.2, and so on.
Mm. Yeah, so another more harder benchmark would be needed in this case. Yeah.
Do you have any intuition on why the task is apparently so simple for this current system, and what kind of cases could be included in a different benchmark that will make it a bit more challenging?
So I need also to think about that. How can we increase the hardness level for the benchmark itself? But at the moment, it would be so hard for me to find something specific to say actually about that. But yeah, I need also to think about that. I'm just writing that down.
But I think that maybe Ernesto has the answer on this. I see he unmuted. Turn on
I'm
video, ready to answer.
I'm here. Yeah, that's something we failed, partially failed last year. I mean, we have this automatic dataset generator. We've tried to add noise, but the problem is like we use the knowledge graph as a source to generate the tables, and then the generator adds some will have some profiling phase, it has some noise, and it tries to transform a bit the data. But in any case, the data is probably very close to what is the target knowledge graph in any case. So this year we are trying to see, we build the tables from DBpedia, for example, and then the target is Wikidata, and then Octite, that is the main person behind the generator, is also working on ways to make it a bit more complicated, because we realized that systems were very good at somehow back engineering all the noise and the stuff we were adding to the data set. And then luckily the last year we had the tough tables data set, and there you could see the difference, because with the automatic 4 rounds were automated data set, and then also the 4 round and round number 4 we introduced also the staff tables. Nobody knew about this data set, and then we could compare that the performance was decreased dramatically. But this data set was semi-automatically created, so it contains a lot of noise, and then Vincenzo was behind the staff tables data set, and put some effort on creating real tables, and it's something we need to move forward, no, because it's in JenTab, because we need to get closer to the real table we find, no. And then of course on the other hand, we need new data sets every year and every round. So we need to have some sort of trade-off between this semi-automatic way of creating data sets and the automated generator. And then this year we have some ideas. Let's see if they work. We cannot promise anything, but we know the problems.
Thank you so much.
I saw also Maria Esther. She was raising her hand. Maria, do you want to add something?
Hello, how are you? Actually, I was going to ask if in the generation of these benchmarks, are you considering also real data? Because all these benchmarks sometimes are very far from the problems that are including, are very far from the problems that we have to face when we are integrating or we are solving this task in real world data. So for example, I'm working in the biomedical domain, and many of the problems that we see there when we are trying to link data, or when we are trying to solve some of these tasks, are not in these benchmarks. So it should be good if you try to also to go and see in the different domains the different type of real problems that at the end we will need to face.
Yeah, indeed, no, like, because I mean the first year was good to have something maybe simple to start creating like a community, but now we feel the pressure, no, like we need better benchmarks. We cannot continue JenTab with the same, no, because in the end it's like, yeah, we increase 1% and so what, we may have the same problem as other benchmarks, no, like this image.net, no, that the way they were improving was very little, no, and then very focused on the benchmarks. So, this year we will have some a data set on life science. Don't know if it will be challenging enough, but at least it will bring something new as well.
Yeah.
which would be very welcome.
Particularly, you think in solving this task in structured medical data from clinical records. That could be fantastic because you can imagine in the short clinical records, the amount of knowledge that is encoded there is extremely necessary for the task of knowledge graph creation and data integration, but the amount of errors that are present there. Why? Because the clinicians, when they are writing these notes, they are always in a hurry. So, and they are not paying attention, even they have many misspelling errors, or they use abbreviations that they only know, and these are real challenge that we need to face and also to evaluate.
Yeah, we need to keep adding new data sets, and I mean the problem is it requires some manual effort. That's the limitation. That's why on the other hand we thought, okay, let's have something automatic, but at the same time with going full automation, we are struggling to bring the same challenges, and that's the thing. That's hard
Yeah,
to have
because
the same thing.
if we are thinking just in automatic generation, at the end we are going around the same problems that we have. We are not opening the door to new problems that exist in the real world.
And especially if we use the same target knowledge graph, I think probably we change just Wikidata by DBpedia, and then the target is the other one, or things like that. We may add this extra challenge. I don't know, but then I agree. We need to find ways of plugging in the real challenge.
Including real noise.
Yeah.
You know, no making up noise.
Yeah, exactly. I mean, with my students, just Googling in Kaggle, I found a very challenging data set about pizzas that is not obvious to match.
Yeah, exactly.
So, I mean, the thing, we have the data set, and we need this extra manual creation or something in between, you know, that enables to have like data sets very quickly for every year, every round, but at the same time challenging.
Yeah.
I would suggest, because
we
we're
need to move
almost
on.
in the panel, but
Yeah,
we
we
still
can
have
jump
one.
into in the panel.
Exactly.
So, we still have one presentation, so I would suggest, hold your answer, hold your debate for the panel. We have a relevant question as well, I think, but let's let the last speaker first give us his presentation.